Okay, start in a sec. Hey, gang.
Hi, fam.
Hello.
Hello. Right. So, let's get started. It's so nice to see all of your faces on this wonderful hump day.
Yes, indeed.
Mm-hmm. All right. Okay, so let's go through this review, and then if you have any questions, obviously, don't hesitate to let me know.
Can we unsubmit it so we can write with it?
Yeah, that's fine. Do I have to do anything like that, or can you do that on your own end?
Yeah, we just can't submit it.
Yeah, that's fine. Yeah, don't worry about that. That's no big deal. You guys are doing all your work. Not really worried about that part. Oh, Miss Ward needs to join. There's our TikTok star. All right, so let's see if this works. All right. All right. So concepts and vocab. I didn't fill them out. I figured I'd just kind of tell you what they are. You probably already have them. Voltage, it's just the potential difference, or it's the ability to do work, stored electrical energy, anything along those lines. And we measure voltage in volts. Current is the flow of electrons. And it's measured in amps. Resistance is anything that impedes the path of electrons flowing. It's measured in ohms. And power is the rate at which work is done. It's measured in watts. Two. So two, if you see a picture and it was asked if it was series or parallel, you should just be able to know the difference. Series just means single pathway, parallel, multiple pathways. So, if you trace it with your finger, if you can make one path and only one path, it's a series. If you can make multiple pathways, it's a parallel. Who just joined us? Gosh, okay. Switches. So switches are either open or closed. If a switch is open, that means it's off because there's a break in the pathway. If a switch is closed, then the circuit is on because the pathway is complete. I always thought of switches as a bridge. If the bridge is open, cars can't get across. If the bridge is closed, cars can get across. Cars are cars. Five is later on. Just know again about current rule. All the current that flows into a junction has to leave. So if 10 amps goes in, then 10 amps have to go out. And then the other part for 6 about the voltage drop, if a circuit is powered by a 10-volt battery, every item in that circuit has to zap some of that 10 volts out so that by the end of the circuit, the voltage is 0. So if you started with one resistor and a 10-volt battery, that battery has to use all 10 volts up. If you had two resistors and each of them were equal, each resistor would take 5 volts up. That's the voltage rule. For section 2, so the website you guys did, the virtual website, I'm going to do the same thing. I'll just be up front. I'll ask you guys to make a picture or make a circuit that works, and then you'll just send me a snapshot of you guys doing it, just like before. And just, I think I put it in there, without catching on fire. So if your circuit is catching on fire, it means you have a short circuit. So if you see that happen, it's not good. You can always, if you get really stuck, you can always shoot me a picture during the day of the test, and I'll see if I can kind of help give you a hint about what you should get rid of. But if your circuit works and doesn't catch on fire, that's all you have to do for that. You guys did really well with that when we did the practice stuff. And then just make sure you can build all sorts of combinations, like a parallel, a series, and then the ones that have both in there. And then also make sure you can put switches in the right spots. You guys, last week we had a practice assignment like that, and you guys did really, really well. So it'll be the same thing as that. Any questions so far? Okay. And then the last part, it says identify what works and doesn't work. So if I drew a circuit out and I had a switch on there, I might ask you, hey, this switch here, which light bulb would it power? And then maybe the A, B, C, or D, and then you just pick the right answer. That's all. Lots of visualization stuff. Okay, so that is that. So that's the concept parts. Any question about the concept part? Okay. All right, so let's go like this. Do you guys see a PDF now with like my handwriting on it? You can say yes or no. I don't actually see your faces. Let me see. Screen share. Oh, here we go. There. Now do we see my beautiful handwriting? Okay. So section 3 is that Ohm's law. V equals IR, P equals IV, P equals I squared R. Those are the 3 equations. So just be able to use them. I didn't put them on the sheet. I'll give them to you guys tomorrow. What is resistance? 75 ohms. And then to find out power, I used P equals I times V, and I got 0.12 watts. For 2, you have a 1,000-watt mixer, and it has a resistance of 40 ohms. How much current does it draw? So since you have P and R, you have to use P equals I squared R. When you solve for I, you get 5 amps. It's 1,000 divided by 40, that's 25. And then the square root of 25 is 5. And then for B, what voltage needs to produce a circuit? V equals IR, or I is 5, and R is 40, 200 volts. Ooh. Okay. I just realized, I'm looking at this key right here. No circuit printed out on my paper. I couldn't see it. So the answer to number 1, I just looked. The total resistance is 30 because the 2 resistors are 10 and 20 ohms. And the battery has a voltage of 90. So the current would be 90 over 30 or 3 amps. So that would be 1. Two, find the current across each resistor. So to first do that, you would just do Ohm's law for each problem. Remember, it's a parallel circuit. Parallel circuits, every object has the same voltage. So each resistor is getting 9 volts applied to it. And then if we do V equals IR, we get the following voltages, or sorry, currents: 3 amps for the top one, 1.8 amps for the 5 ohm resistor, and 1.5 amps for the 6 ohm resistor. All right, and then to find the current across the battery, since it's a parallel problem, you have to do the inverse. 1/3 plus 1/5 plus 1/6. I found the least common denominator, which is 30. Get 21/30. So R is the reciprocal, 30/21, which is 1.43. And then if you solve for I, you get 6.3 amps. Any questions on 1 or 2? Okay. 3. All right, so 3, let me share a better page first because my printer is garbage and did not print out the circuit for some reason. So 3, the circuit has, it's a combination circuit. It's got series and parallel stuff in here. So before we can solve, we need to first find out the equivalent resistance for the 4 ohm part and for the 10 ohm part. So we have to find out the resistance for this and for this. So if you solve for the resistor, this first one, 1/4 plus 1/4 is 2/4, and then the inverse is 2. So this really becomes 2. And then when we do this one, same thing again. For this part, it's 1/10 plus 1/10 is 2/10, which ends up being 5. And then we can solve for this as a regular series problem. So the total resistance is 2 plus 2 plus 5 plus, oh, I wrote 10 on my paper by accident. It's 1, I misread that. So the total resistance is 10 ohms. And then we can do V equals IR, 10 equals I times 10. If you solve for current, you get 1 amp.
Wait, how did you find current for this one?
So we would do V equals IR.
Uh-huh.
The voltage is 10.
Yeah.
And then if we add all of these resistors up, 2
It's
plus this
10.
red 2 plus 5 and 1. That gets you 10.
Okay.
So that's that was 3. Any questions on 1, 2, or 3? Right. So let me go down and erase all this. Number 1, this solve for I2, all this stuff, you don't actually have to worry about this one. I would only ask you to find the current across the battery for this. This would just be like the one before. So don't worry about solving this via Kirchhoff's rules and finding out I1 or I2 and I3 and all that good stuff. Don't worry about that. So if we were just going to solve this like the one before, because that's all you're going to have to do on the test for something like this, first take care of this parallel part. So 1/R is 1/6 plus 1/12. All right, that ends up being 3/12. So when you flip it upside down, R is 4. That gives you a total resistance of this 4 and this 4 for 8. So when you find current, it's 12 equals I times 8. And you end up with 1.5. Right. And then the last one, so this one we could do as Kirchhoff's law, So here's what we know. We're given IA and I1 and I2, and they want to find IB and I3. So what we know is this. IA, oh, can you guys still see me? Am I still here? Okay, my internet's crudted out. All right, I'm sorry. So IA is equal to, at this part, I1 plus IB. Because the current flowing in is IA and the current flowing out is I1 and IB. We know IA is 7. We know I1 is 2.5. So if we end up solving working backwards, we can find out IB. 7 minus 2.5 is 4.5. So IB is 4.5. We can then say,
Can you explain that? I did not understand it.
sure, yeah. Okay. We know the current going in is 7 amps. That's IA right here. That's this guy right here. Kirchhoff's current law says all the current going in must be equal to the current going out. So if 7 amps goes in, then 7 amps has to go out. Going out of this first junction that's labeled like lowercase a is the current IB and I1. So we can say that IA is equal to I1 plus IB because they both have to add to the same number. In that case, the number is 7. So if we know IA is 7 and we know I1 is 2.5, IB is our unknown, and we would just work backwards to solve for IB, so we subtract 2.5. Does that help clear it up?
Yes.
Okay. So then we know IB is 4.5. Well, we also know this. Same idea. Going into this spot here at B is the current IB. Leaving this current here is the currents I2 and I3. Well, I2 we know is 1.5, and I3 is what we're trying to find. We know IB is really 4.5. So we can say 4.5 equals 1.5 plus X. If we solve for X, we would get 3 amps. And that would be the other current. And if you wanted to make sure you're right, if you look at the picture, I1, I2, and I3 all go back to the battery. So they all have to add up to 7 again. And if we add them up, 2.5 plus 1.5 plus 3 ends up giving you 7. So just another way to check your work.
Can you explain how you got I3 again?
The second
I'm
part with
sorry.
I3?
Yeah, I3. Like
Yeah,
how
no
you got
problem.
the 1.5.
Yeah. Okay. So we got IB to be 4.5. Are you okay with that part?
Yeah.
Okay. So at B, IB flows in. Nothing else flows in. What flows out of
Okay.
IB? I2 and I3. Now we'll just plug in what we know. We know IB is 4.5. We know I2 is 1.5. And I3 is what we're looking for. So we'll just leave that as I3. You call it X, whatever you want to call it. And if we work backwards, we subtract, or not work backwards, we solve for I3, we subtract the 1.5 to both sides. 4.5 minus 1.5 is. Okay.
Mhm.
That's really the review. You guys are going to do really well. It's a pretty easy test. I'm not gonna, just so you guys know, if anybody asks, I'm not gonna post the answer key. If people didn't want to watch it live, that's cool, but like the answers are all right here on this. So you got to see the key before anybody else. All right. Any other questions? Are we staying sane?
Yes.
Yeah,
Mhm.
good. Josh, you doing all right?
Yeah, I just ran, so I'm kind of tired right now.
Of course you did. Well, Josh, think of it like this. Here's a benefit to not having school anymore. You don't have to ask Bridget ask you if she got a parking spot every day. I'm just saying like that's not gonna happen anymore.
I mean, Josh, did they say anything over this break? Like about you getting one, maybe?
They might have given him one now. Like nobody's at school, so Josh, you can have any parking spot you want. Pick of the litter.
Sounds good to me.
Fal, can you explain the first question in section 5? I'm so confused on that one.
Yeah. Oh, so you know you don't have to find I1, I2, and I3, right? Like I can show you how you do that too, but I realized there's a lot more steps involved in that we didn't get to cover. And it would have made sense if we were in school and we could have worked more hands-on, but doing it this way, it's going to be a pain in the ass to do. So,
All right.
but like, what you should be able to do, because what like would be expected of you would be to just solve for the total resistance and then find the total current through the battery.
Okay.
So again, if you ever have a compound circuit, you want to collapse every parallel part first and then solve it like series. So for this one, if you can find out the total resistance between the 6 and the 12 ohm resistor, doing 1/6 plus 1/12, that gets you 4. And then the new 4 ohm resistor and the original one that's R1, they add together to get you the 8. And then you can just do V equals IR.
Okay, thank you.
No problem. Like there is a way, there's a lot more steps to solve for it for I2 and I3. And I just didn't think that part through when I made it. And you guys, it's just too much to ask of you guys in these current times.
All right.
Yeah, this is not worth it. Anything else? All right, so again, you guys will have 2 days to take it. Tomorrow's the multiple choice and the PhET questions, and then Friday will be the math. And that way you just can take your time. That way you have to race through it in one day.
Do we have to send you pictures of the math stuff and everything?
No,
last
so I think
time?
I'm gonna do is I'll make everything like a Google form because it'll be a lot easier. I'll make the numbers really easy to work out. If I'm going through and all your math is really bad, I'll ask you for a picture to
Okay.
give you partial credit. So I'll remind you guys to take a picture just to save it, but you don't have to send me anything if you don't need to. But I'll try to make all the answers work out to be either like 1 decimal after the answer or all whole numbers.
Okay.
Again, just to make life easier. Because I can't, to go through and try to like mark individual points on your paper is a nightmare. So I'd rather have it as easy as possible, like not to lie, like to be easy on my end too.
Okay.
Anything else? You guys are all frozen. Lex, you look really angry. You're frozen my computer with this real angry face. All right, well, guys, if there's nothing else, I'm gonna go relieve my wife and take care of Ellie. So I'll talk to you guys later.
Bye.
Bye. It's good seeing you guys again. I miss all of you so much.
You
Bye.
too.
I know. Next year, we'll see each other next year.
Of
We'll have a
course.
quick impromptu 9th period get together in the hallway, even though, because you guys always seen your options, so it's cool.
Okay.
Hasta luego, friends. Bye.
Bye.